Hi class, how are you today? That's great! As many of you know, at the end of the school year, I always like to make a special video. I've made one every year since I've been here at Maranacook, and this year is no different. This year, I did something a little different where I told everyone ahead of time what the video was going to be, and I asked for recommendations. I asked everyone if they could send me math-related videos. And I told them that I would react to these math-related videos. I asked them if they could be 10 minutes or less, but the shorter the better, so I could get as many videos in as I could. I received 12 submissions. Some people sent multiple submissions, but I got 12 videos total. And today I'm going to react to them. Let's get started. Alright, Mr. Babbitt from the future here. This video didn't turn out as well as I would have hoped. The audio for the videos didn't record very well. So this video's gonna look a lot different than I had originally hoped. If you want, you can watch a lot of these videos beforehand. I'm going to put all the links in the description, and it might make more sense if you do so, but you don't have to. Just know that the video might turn out a little weirder than I had originally hoped. Either way, I hope you enjoy. So the first submission I actually got was actually for a channel, not a video, which I thought was strange. But when I went to click the thumbnail, one video came up as a suggestion, I think. So I'm going with that video. I'm assuming that maybe this was the video the person was talking about. And so let's react to this video. First of all, it says, "Can you solve this?" Well, let's solve it. Before I even start the video, I want to solve this. So it's 5 minutes and 32 seconds long, so I kind of wonder what they're talking in here about. It's very interesting, just because there's not a whole lot going on, but maybe they did get into more. I've never seen a video like this. I've never seen anything from this channel, so I'm very interested. So let's try solving this. Well, order of operations says you do parentheses first. So inside the parentheses, we have 1 plus 2 is 3, so this is going to come down to 6 divided by 2 times 3. And then order of operations, even though, and I wonder if they're going to say this in the video, but even though we have PEMDAS, which has parentheses, exponents, multiplication, division, addition, subtraction, multiplication, division go together left to right, and addition and subtraction go together left to right. So the fact that we have multiplication and division left, because remember 2 times 2 and 3 next to each other mean that they're multiplying, we're going to have 6 divided by 2 first, and then multiply that by 3. So 6 divided by 2 is 3, and then we have 3 times 3, which is 9. So I'm saying that the answer is going to be 9. It's possible they come up with something different, though in my mind, if they do, they're wrong. But let's see how they decide to solve this. I'm very interested. So stopping here, I've never heard BODMAS before, and I've also never really heard people use brackets or orders before. Like, brackets can be used just like parentheses, and often they're used if you have parentheses and brackets. But I assume that's probably like a European thing, possibly. But I usually go with parentheses, exponents, multiplication, division, addition, subtraction. And like I said, it does show here we've got multiplication, division together, addition, subtraction together, just like I said. And left to right otherwise. Yay, I got it right. I didn't specifically put the ets. I don't like using ets for multiplication. I prefer a dot or having two sets of parentheses next to each other or a number next to parentheses, which is what I wrote. I don't like using the ets because then I get confused on if it's a variable. And ets should be for variables, and it's kind of a pet peeve of mine that ets is used in multiplication instead of just a dot or some other symbol, but yeah. So 3 times 3, which gives you 9. I am correct. Yay! Oh. Okay. That makes sense. And I can see that. That's another thing. I really don't like this division symbol either. Write it as a fraction. That's what division really is. I know that is difficult to do on computers sometimes. Usually need some sort of math equation editor. But I don't like this division symbol. And so that's what gets things confusing in this, and that completely made sense. And that is a tough one. I would say division comes before multiplication, but it's all about what this symbol means. So I can see where they're getting at here with the historical usage, and that's how it used to be used. I just think we shouldn't use this symbol. But that's just my opinion. Okay, so one other thing that I should mention is that, so the calculator does have a division symbol, and it uses the slash instead of putting the division symbol, but it works the same way, and you do have to do it that way and say left to right division multiplication all together. And so if you are saying everything under the division symbol, or if you want to say everything after the division symbol is being divided, then you have to put it around parentheses. Otherwise, your calculator is going to interpret just the immediate thing after. So you need to be careful with that, and I know that's some issue that people get into when using the calculator, but that's one thing you just got to remember. When in doubt, just always use parentheses in your calculator as much as possible. All right, let's go on to the next video. All right, so this next video is called Math Videos, How to Learn Basic Arithmetic Fast, Online Tutorial Lessons. So this next video seems to be about learning basic math fast. I would love to watch this and react to it. It seems like it could be very helpful to get good at remembering how to do math quickly in your head, that kind of thing, and probably a good video. However, I'm sticking to my rule. I asked everyone to submit videos of 10 minutes or less. So unfortunately, this video is 1 hour, 12 minutes, and 8 seconds. I'm not watching it right now. I probably won't watch it ever. But if you want to learn basic math fast, it's probably a good video to watch. But I'm going to skip to the next video. All right, this next video is called Finding the Asymptotes. So I assume it's going to be all about finding the boundaries of which graphs go. So when you draw graphs, they have lines that they never cross. They're probably going to talk about that in the video, so I won't do a lot of that right now. But if I feel there's explanation needed at the end, I will. So what we have here are 3 functions, and each function has division in it. So whenever you are dividing, specifically dividing by x or something with x in it, you're going to end up with asymptotes. And so the graphs will go on forever, but never touch the asymptotes. And so I assume they're going to talk a bit about that video, so I won't talk about that much here. But let's see what this is. I'm pretty sure he's saying asymptote, not asymptote. just a pet peeve. What is that A? Okay. Very good on doing the plus or minus square root of 3 there. A lot of people forget that when you take the square root of both sides, you need the plus or minus, because x could have been positive or negative square root of 3, and when you squared it, it became 3. It sounded like he just questioned someone to see if he was doing it right. Maybe he was just asking a student, like if they understood, possibly. Not sure there. Also, another pet peeve, I don't know why he put the apostrophe on degrees. He didn't put it on coefficients. Why would he put it on degrees? That you're just saying multiple. The degree is not owning anything, and it's not a contraction. Big pet peeve that people put apostrophes when you're just saying there are multiple of these things. Big pet peeve of mine. Okay. Okay, so it does seem like he's teaching a class, or at least one person. So he's recording himself and teaching to an actual class at the same time. I really prefer to make my videos separate from teaching. Also, it makes it easier and nicer so I can edit later, and a lot of mistakes I make, because I make a lot of mistakes, don't show up as much. If I did not edit my videos, they would be so much longer than they actually are, just because of all my mistakes. Okay, so he also appears to have these like ad things in his channel. It's getting in the way of the video, and that bugs me in videos where there's actually something I want to see here. I don't do those for my videos. I don't like doing any of that. I know a lot of students say I should advertise my videos or monetize my videos, and but then as far as I know, there would be ads at the beginning and possibly other places. I don't want that. I make my educational videos for education and possibly a little fun. But I'm not looking to become a big YouTube star, and so I don't need this advertising my other videos. I definitely don't do it. I've been working here for 6 years, and I have around 60 subscribers. So I'm not trying to build my channel. I'm just trying to educate and have a little fun. So someone was asking a question at the end, and they didn't get it answered in this video. Okay. Other thing I want to say is overall that was a good video. Like I said, I made so many mistakes. I would make a lot more mistakes in my videos than he did in his. So nice job. It was very well done video. I don't think I've ever actually taught asymptotes before, so I'm definitely not an expert when it comes to asymptotes, but everything I knew about that seemed to match what I know. Alright, so this next video is called What is Pi Choose 3? So whoever's making this video must be talking about combinations, and I think I'm going to talk more about it at the end, because a lot of what I want to say is probably on here. I will say I don't know what pi choose 3 is. I've only ever used combinations with whole numbers, because it involves factorials, and factorials are all about multiplying by a number and every number after it. So to my knowledge, I don't know how to do combinations with numbers that are not whole numbers, because combinations are all about you have this many things and you want to choose this many. It's all about whole numbers. So I don't know about how to do it with fractions or irrational numbers like pi is. So let's check it out, and I will explain combinations a bit more at the end if this person doesn't do that. Okay, jump right out of the gate. Love the Pokemon. And the pie shirt with eyes. A little creepy, but I like it. A lot of stuff over here. Math formulas. Looks like a Pokemon and math geek. So I relate. Not as into Pokemon as I used to be, but I do like it, and my son likes it a lot. Okay, a lot going on there, and he went very quick. So, like I said, combinations are all about you have so many things and you're choosing this many, and you want to know how many ways to do that. So, in his explanation, he had 5 choose 3. So, you have 5 of something, and you want to choose 3 of those things, and you want to know how many different ways can you do that. And specifically, order doesn't matter. So it doesn't matter what your first choice is, second choice is, third choice is. It just matters that of those 3 things, how many different 3 things can you choose? And so, yeah, he's using factorials. So it's a little bit more than that, but pretty much that. So using R and K like he did. So if you have R things and you're choosing K things, the formula is going to be R factorial over K factorial times R minus K factorial fraction continuance. So on here we have 5 factorial over 3 factorial times 5 minus 3 factorial. So that's going to come out to 5 factorial over 3 factorial times 2 factorial. Now, since 5 factorial is 5 times 4 times 3 times 2 times 1, 3 factorial is 3 times 2 times 1, and then we have 2 factorial is 2 times 1. He pretty much took a quick shortcut and said, okay, we don't need these 2 times 1s, and so it's 5 times 4 times 3 over 3 times 2 times 1, and then you multiply those out and solve from there. Now, I'm still trying to figure out the method for pi choose 3, so he has R times R minus 1. His R looks too much like a Y and it's confusing me. And then dot 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 Y minus K minus 1. Okay, so first you have 1, R minus 1, then you have R minus 2, then you have R minus 3, until you get to R minus K minus 1. Okay, that made sense. So in his explanation, if you use the 5 and the 3, we're going to have, so for 5 choose 3, we're going to have 5 times 5 minus 1, which is 4, times 5 minus 2, which is 3. And we stop there because we go up until K minus 1. So we don't do 5 minus 3. And then over K factorial, so 3 times 2 times 1. 1. Okay, and that gives you what we had over here. Great. Okay, I've never seen it in that formula before, but that made sense. So if you use that, and I don't know if that's correct, I've never seen that formula before, but if you go by that, then you have pi, so r, which is pi, and then r minus 1, so pi minus 1, and then pi minus 2, and you stop there because you go up until k, and then you multiply that out and divide by 3 factorial, which is 3 times 2, which is 6, and that's how you get that. And then you multiply that out on a calculator. Okay. Assuming that formula is correct, that made sense. Now his question of what is pi choose e? Well, I don't know how to do e factorial either because e is also an irrational number. So that goes much farther than this video goes because, again, I only know how to do factorials of whole numbers. So that seems like it's going to be a lot more than this is. But what was taught in this video made sense. Okay. All right. This next video is called Math Has a Fatal Flaw. And I actually know this channel. And actually, I've heard of this video because YouTube recommends this video for me a lot. The channel is Veritasium. I've seen a few of their videos, and they're really good. They're usually pretty long, so I haven't seen a lot of them. They're usually at least 15 minutes, if not more. A lot of their videos are around 20 or more minutes. This one is 33 minutes and 59 seconds. I would love to watch this video, and I actually plan to watch it at some point. It's been recommended for me a lot. I plan to watch it. I will note that this video used to be called something else, I'm pretty sure, or at least the thumbnail was different than it is now. The thumbnail says incomplete, I think, but before it said a hole in math. So they changed at least their thumbnail. I don't know if you can change the title of videos. But that's just, I've seen this video recommended to me a whole bunch, and I am interested to watch it, and I plan to watch it soon, but I'm not going to react to it here because I said a limit of 10 minutes, and this is just too much for this video. But I will watch it soon. Alright, so this next video is called Metamorphosis and Introduction to Functions. I assume they're going to somehow compare functions with meat, maybe? Or taking meat and turning it into something else using a function? That makes sense. So functions are all about putting in something and getting something else out. So I assume you're going to put something into this meat function and get something else out of it. It's a little scary. I feel like you might be putting in animals and getting food out of it. But I mean, that is how meat factories work. Okay. All right, let's see what this video has in store for us. Ermertainment Omnimedia. No idea. I'm going to guess right now that this could be a student-made video for a class explaining functions in a student-made video. If so, that sounds pretty cool. I'm interested. No! Ugh. Why? Why? Bite-sized revolution, the nuggetizer, ground up, recompressed meat products, no longer just food service fantasy. And then they have lorem ipsum. That's just random. But lorem ipsum is a thing that I know that they put just to have words on there, but it means absolutely nothing. So all of this is complete gibberish, except for the big words. Yes, like I was saying, you input something, you output something, and I was worried about this. Okay, I mean, it's real, it's what happens. Poor cows. Steak fingers? That just sounds gross. Fishies! Fishnets. When are we gonna get to the math? Piggies! Rip! Oh my god! Oh, McRibs taste good. I'll give them that. Okay. I'm pretty sure functions came before nuggetization or, well, meat factories. Uh, Pretty sure functions were around a lot earlier than meat factories. Yep. I don't think I know either. Okay. Hypotenuse, I'm pretty sure is Greek. Uh, Asymptote, I don't know where that comes from, either probably Greek or Latin, as everything does. I have no idea what a lemon skate is. That's not a term I've ever heard before. So I wouldn't say the same people who came up with those words came up with domain and range. Yeah, I don't think domain and range are Greek, and hypotenuse is definitely Greek. So, well, I think it's Greek, right? I mean, it came from. I guess it didn't come from Pythagoras, who was Greek, I think. Anyway, I don't know what lemon skate is. Vinculum? Pretty sure they made up the last three. Output should be 2. Output should be 14. Output should be -6. Made sense. I mean, interesting. Ooh. Identity functions? I think these are identity functions, where you output the same thing that you input. So multiplying by 1, adding 0, that'll get the same thing that you input become the same thing that you output. Yeah, y equals x. I mean, if you look at y equals mx plus b, in this case, m is 1 and b is 0. You're multiplying by 1, adding 0. So you get the same thing out as you put in. So they had 1. This is going to come out 1. Every number will come out the same. That sounded like a fart noise. Spam! Spam! Everything's in spam! I don't know if I've ever had spam. Yeah. Okay. I don't know where this is going. Oh, of course, yes. The constant function. So the constant function is no matter what you put in, you're going to get the same thing out. So everything that they put in here, it's going to come out as 6. Doesn't matter what it is, it's going to output 6. Can I predict the output of the next machine? Probably. -8. Quick math, 9. -11. Interesting. I like that. Input 2, output 4. Okay. Well, at this point, I think it's doing one of two things. It's either adding 2 or multiplying by 2. But we'll see later on. So it's either x plus 2 or 2x. I was wrong. I forgot. Squared. It's squaring because 2 squared is 2 times 2, which is 4, and 5 squared is 5 times 5, which is 25. So this is y equals x squared. So this should be 9 because -3 times -3 is 9. Yep. I did. Oh. As morbid as this video was, I found it very entertaining and educational. I no longer think it's made by students, because I thought the quality was pretty good, but I'm pretty impressed if this was made by students. That's pretty awesome. I like this video. As morbid as it was, yeah, it was entertaining. Oh, that's where the ermitation or whatever it was came from. Alright, so this next video is called Infinite Chocolate Bar Trick, Chocolate Magic, Chocolate Trick. I don't think I know what's going on here. I definitely have not seen this video before. Let's check it out. Alright, this was a short video, so I'm going to have to rewatch that. I have seen something like this before, but I'm not exactly sure. I don't exactly remember how it works. One thing I'll say here is this could be an optical illusion, because right here that's much smaller than any of these other pieces are, even over here. So I think they actually did make it smaller, but let's go back. Okay, so we have 2, 3. But 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This looks so much bigger than this, and I don't know why. I feel like this is an optical illusion somehow. So they cut that. Yep, they already did that. And then they cut that. Cut that piece. I'm pretty sure this is some sort of illusion, and I do also believe that the bar got smaller. While I'm still lost on how there's the same number of squares, the squares in some cases definitely here are smaller. So I think it's losing mass, and I think this is just some sort of optical illusion or trick of some sort. That's as much as I got. If anyone knows more about this, I would love to hear more. I don't have much more than that. Alright, so this video is called Kid Snippets Math Class Imagined by Kids. I don't know. I've never seen this video or anything like it. Board Shorts TV, that's completely new to me. Let's check it out. So it sounds like these kids are dubbing this teacher and possibly trying to say what he's saying. I'm kind of wondering if he's going to start saying words that they don't understand and they're just going to come up with new words. Let's see. When I was in high school, it always bugged me when people said takeaway instead of minus. It doesn't bug me anymore as a math teacher. I don't see it as much as I did when I was in high school either, but there are some people that do it, and that's perfectly fine. When I was in high school, though, it just bugged me as more of a, because it wasn't mathematician-like, but it's the same thing. It's just another way to say minus or subtract. Also, counting on your fingers is perfectly fine. Everyone does it, even me. While I definitely don't have students anywhere near this, I do have students that often rush past counting. I see that a lot, and they'll count 2 numbers only once, so that does come up. Going too fast can be a problem, and it's perfectly fine to take things slow. That's why I don't like time tests. Don't go too fast. It's perfectly fine if you take your time to do your work and count your fingers. Yeah, I have a lot of students that will tell me that they get it when they don't get it. It's all about understanding when a student actually does understand, and sometimes I even have trouble with that. But I often have to figure out when a student actually understands because they think they'll get it and not always do. And it's easy to do that. Like you watch someone do something, you're like, oh yeah, that made sense. And then you go to do it and you're like, how do I do that thing? I forget. And so that's why I love to give practice as much as I can, because actually doing it is where the understanding comes and where you know you can do something because you've done it yourself. Overall, this video, like it really overemphasized uh, issues teachers can have with students. I know there are plenty of times where students will have trouble answering what seem like simple questions. And I mean, that happens. Everyone struggles to do basic math, even me. Just sometimes just thinking of something very quickly, it you just mess it up or it doesn't come to you for some reason. That happens. I wasn't a huge fan of this video though. It just went really far and uh, made made those kids look stupid. All right, this next video is called Math Rap Dougie. Teach me how to solve it. Equations. Okay, I'm guessing this is a parody of the song Teach Me How to Dougie. I don't even know if that's the name of the song, but I'm pretty sure it's a parody of Teach Me How to Dougie, and they're going to say Teach Me How to Solve It. This also looks like it's probably student created, so I'm very interested to see. I feel for this teacher. That's all I'm gonna say. I feel for this teacher. Okay, that was very bad lip dubbing right there. This is fun though. I like using the shapes. It helps a lot of students know which terms to combine. I do that as well. I like that method. All right, I like that video. That was cool. It was a parody, and I love parodies. As most people know, Weird Al Yankovic is my favorite singer, and he does lots of parodies. So I love parodies. Math parodies are great. The dancing was fun. Everything he said appeared to be correct, and yeah, I overall liked the video. All right, so this next video is called All I Do Is Solve, WSHS Math Rap Song. So this looks like it's probably a parody of All I Do Is Win. So another one like the last one. It's probably gonna, I don't know if it's gonna teach anything, but probably. And it's going to be a fun math song, I guess. Let's check it out. All right, so this seems to be a song about solving systems of equations. Okay, so probably going to go into all three and explain how to solve them. Cool. So he said something about when it's easy, that's when he likes to graph. I agree. Graphing can be really easy when they intersect at nice points. When they intersect at fractions and decimals, not as much. So sometimes graphing is really good, sometimes it's really not. I usually like to teach graphing, then substitution, then elimination. Probably because elimination's my favorite, and I like to save the best for last. But to each their own. Okay, that was also a fun math parody, and I really liked it. These types of songs can be really good, especially when students are having trouble remembering some steps sometimes. Some songs like this, if you can remember the words, it will help you remember what to do. I don't know of any math songs like this, but there is a Weird Al song uh, called Word Crimes. And there are some things that he says in there that help me remember when to do different things with grammar. And so I'll just replay the song in my head, and it will help me remember what to do in a specific situation. And so math songs can do the same thing. And so I think these types of songs are really helpful sometimes. Mr. Winner. Okay. Schultz Murphy, I believe. Winner? Okay. Sure, like maybe that's his actual name. Math professors be like. I'm guessing this is someone making fun of what math professors do. That's just mean. Pretty sure it's not correct. I haven't done multivariable calculus in quite a while, but I'm pretty sure that wouldn't work. I am impressed that he rewrote that without messing up, because this person does not actually seem like a math professor. I don't do curve. I honestly wouldn't. I've never looked into how to calculate on a curve. I don't like doing that. Okay, I purposely never say who got what score during class, as much as I would love to congratulate someone for doing well, even if it's in a way where like someone doesn't usually do well and I want to like, hey, very good job. I don't do that in front of the class. It's just not right. Keep names out of it. Okay, the homework is just good to do. It's a bit more than that. Math professors don't grade from homework usually, and that's one of the reasons I like to do the same thing. So yeah, in college, there's usually a midterm and a final exam, and usually they encompass everything that the class covers. That is one thing I don't like to do in my classes, especially because time crunch and trying to get through material. But yeah, like review often looks like that. They'll say, hey, cover these things. But oftentimes math professors will also have study sessions available and do a lot more review than just say, hey, cover these chapters, notes, and do all the homework. Okay. Yeah, that's happened before. But that's more like I'm trying to go over something, and at the last minute, I just don't have time to go over it. But that doesn't happen a lot. As far as I know, there are only 3 calculuses, usually. I took Calc 1, Calc 2, and Calc 3. So I don't believe there is a Calc 7. I have no idea why he's calling that abusive. I never heard a math professor call something abusive. Those look like matrices. I prefer to use brackets instead of parentheses for them. Okay. It's just making fun of college math professors. Some of this stuff is true. Some of it, most of it's just way overboard. But yeah, college math professors and high school math teachers are very different. One thing I will say is high school math teachers usually go to school for education, possibly also math, but college professors, they go to school for math, and then they happen to end up teaching. All right, so we've got one video left, and it's called Subtractions for Kids. Learn to subtract with dinosaurs. Mathematics for kids. I want a cupcake.
In one bite? You're never full. Are you still hungry?
Yeah. Okay, so that was a nice video to learn subtracting and make it fun. It's interesting that they did 2 different methods. They did vertical subtraction and then horizontal subtraction. I feel like there's not a huge difference between the two when you're dealing with single-digit numbers, but when you're dealing with double digits, then it's much easier to switch to the vertical. So that's probably why they showed both, because a lot of times you'll see it in the horizontal method, but then you'll want it in the vertical when you do multiple digits later on, so they want the students to get used to subtracting vertically as well as horizontally, even though there's really not much of a difference when it's just one digit. Alright, well that was the last video. I hope you all enjoyed me watching and reacting to the videos that you suggested, and have a good night.